The objective of this video is to state the boundary and initial condition of the problem, approximate the heat distribution after half an hour using finite difference approximation, construct analytical solution, and to discuss the accuracy of the approximation solution. The heat equation is a partial differential equation that describes how the distribution of some quantity, such as heat, evolves over time in a solid medium as it spontaneously flows from places where it is higher towards places where it is lower.
Okay, now I will explain to you which is what is analytical and numerical solution. So basically, analytical solution is using the separation variables methods, and numerical solution when we use formula of linear second order PDE. So separation variables methods, when we assume the original function of two variables as a production of two functions such uxt equal to x, xt, and t, and then the PDE will be reduced into two ODE which solve separately and combine the solution of PDE to give answer of solution for corresponding PDE. So a partial differential equation involves partial derivatives of an unknown of two or more independent variables, and we will use the general form of linear second order of PDE.
Okay, for question B, using finite approximation, we have to approximate the distribution after half an hour. So, using the approximation, we have to determine or decide the value of h and k. So, since we have length of rod is 50, so I decide the value of k is 12.5, and we have to approximate until half an hour, so I decide the value of k is 3. And coefficient is depend on the value of h and k, so we have to build a formula. Actually, the value of h and k we can decide whatever we want, but the small size of this h and k, we can get the accurate answer. The boundary and initial condition are given. So at x equal to 0 and x equal to 50, the value is 0. Find the value here, we can use the approximation equation that we derived. We get the value after half an hour, and if we want to see this distribution more clearly, we can construct the graph.
Today I will explain how to get general formula for analytical method. First step, we use method of separable variable, and then we get to equation. For analytical method PDE, we have three cases. First, k equal to lambda square. We put inside the x equation, we get trivial solution, so we cannot use. Also the second case, k equal to 0, we get trivial solution. Third case, k equal to negative lambda square. We get Bn sin n pi x over 50. Because of the third case not a trivial solution, we can continue for the t domain equation. So t domain we get Cn e exponent for n pi over 50 square t. And then we put the x equation and t equation together. To find the Bn, we must use initial condition and Fourier series method. And then after the calculation, we get the value of Bn. And then we put the value of Bn inside the UXT equation. That's all. Thank you.
Okay, for question C, solve the equation using analyticals. And we can find the value here using analytical general equation that we derived before. Here we already get the analytic solution, so we can construct graph to see more clearly these heat distributions. Okay, this is the graph for analytical solutions. So
We go through the graph. So when we apply the solution, the formula, and then we get the answer, and we plug in the answer into the table. So we can look at the graph, which is analytic more accurate, and then we can also see at the graph, which is numerical can more accurate if the step size is smaller.
accuracy for numerical, as we know that analytical is more accurate than numerical, right? Since we already approximate the previous question. So, but we can also use numerical solution accurate as analytical by reduce this step size. But before that, let me show you the graph of accuracy. Okay, this is the graph for accuracy. We can see this by click this. Analytical is more accurate than numerical, but when we reduce step size for numerical, we can see how this graph will be. Here we can see, now when we reduce the step size, which is I reduce the value of k, you can see the numerical and numerical is quite same like analytical, right? And also we can see the graph for numerical solution now compared to graph analytical solution compared to before. So the conclusion is accuracy for numerical can be accurate as analytical by reduce the step size.
From this video, we have stated the boundary and initial conditions. We have also approximated the heat distribution after half an hour using finite difference approximation. Analytical solution was constructed and the accuracy was discussed.